Hello everyone, today we are going to start our new chapters about the general pharmacology that start from the pharmacokinetics. The pharmacokinetics, we are going to start enzyme kinetics. The patients using the drugs are mostly worked by the inhibiting and stimulating of enzymes. The first we have to understand about the enzyme. Enzyme is a catalyst that can convert the substrates into product fastly and laboratory. The kinetics means how much quickly process is occurring. First, we have to understand about the enzyme. For example, it is an enzyme and the substrate. Every enzyme having a specific site to attach with a substrate. After attaching, it converting into product and it be that's from the enzyme. Okay? So, in simply we can write one equation like substrate plus enzyme that converted into enzyme substrate complex that converted into enzyme plus product. Fine. And here I will give you one concept like as many substrate is increasing, the velocity kinetic will also increasing. For example, I will make one diagram here. Like there's a one container, second container, and third container. There's an enzyme, and we are putting enzymes in all containers. Now we'll put the substrate. Is only one substrate, two, and the other three. Okay? By that, here having a normal level of substrate convert into product. Here we having mid-air range of products, and we having high level of products. Why? Because if we increase the substrate, the product will also increase. It's a simple and basic concept. If we summarize that concept, then it means adding substrate become more products. Okay? And by these type of kinetics, now all the things, in this chapter, there's a two scientists, the Michaelis Menten kinetics and Lineweaver-Burk plot. We will start from the Michaelis Menten kinetics. The Michaelis Menten kinetics. Michaelis and Mentens are two biochemists that give that idea of Michaelis Menten kinetics, that how the enzyme can work. They give one equation. Before giving you a equation, I give you some points regarding this graph. Here's the one Vmax. There's a Km, there's a substrate S. Okay, what these all mean? The V is equals to the velocity. And velocity means how fastly the velocity of reaction, how fastly the substrate is converting into product. Okay? Like how this concentration of a substrate is converting into product. It is a velocity. And secondly, the Vmax means the maximum velocity, how maximum can be substrate converting into product. The Km is a constant, the Michaelis Menten constant, and they give one equation that is V equals to Vmax multiplied by concentration of substrate and divided by the Km constant plus substrate. From this equation, there are some points can be occurred, like these worked hard during multiplying, and these are some. And according to physics, only that quantities can be added that having same unit. So by this concept, we can say that the Km and substrate having a same constant and the same unit, so that are getting hacked. And that Km is a substrate concentration needed for an enzyme to reach the rate of 1 to max and inversely related to affinity of enzyme of the substrate. It is the constant. How that constant when the verb takes some condition that will be more understandable for you. The first, according to this equation, if I already told you the Km and the substrate having the same unit, if the Km is equal to the substrate, then this equation become V equals to Vmax multiplied by the concentration of substrate divided by Km is equal to substrate. So instead of Km, we're writing substrate plus substrate. And answer will be Vmax multiplied by substrate divided by 2 substrate. Like if we add both, then it becomes the 2 concentration of substrate. The substrate will be substrate cancel with each other, and answer will Vmax over 2. And what is this? Then Vmax over 2. It means the velocity of the product is equal to half of maximum. If this one is a graph and this one is a maximum velocity, then if the Km is equal to the concentration of a substrate, then the velocity will be decreased to half of maximum. This is the full, then it will be half of the maximum. If the Km is equal to substrate, then velocity will be decreased to maximum of half. Okay? And there will be one second condition. Second condition is that the Km is approximately equal to 0. Okay? And substrate is just too high. There's a high concentration of substrate, and Km is near to 0. It's approximate with 0. Then what does this equation become? This equation become velocity equals Vmax multiplied by substrate divided by Km is a 0, so we are not putting Km, and only the substrate. The substrate will cancel with substrate, and answer the Vmax. So by this condition, we conclude that if the value of Km is approximately 0 or very low, then velocity can be equal to Vmax. I think that concept will be understandable for you guys. As I already told you about the calculation of Km that affect the velocity of the product, simply this one is a diagram or the graph they show you here. And theme the thing that I already elaborate you, the V velocity is equal to the reaction velocity or how much mean product you are getting in how much time. Second is the Km constant. This is a substrate. Here, second thing is that already I told the half of the maximum will be occur when the Km is equal to substrate. And I already told to achieve the Vmax that Km approximately 0. Okay? And secondly, if you focus on this graph, the graph is getting up. If I increasing the substrate, the slope is increasing. But at one point, the slope become flat. When the slope is going to start flat, that point is Vmax. Okay? And it's a saturation, of enzymes. And this is a specific point. You can't change the Vmax, but the Vmax can be increased by increasing the concentration of enzymes. The Vmax will not increase by increasing the substrate. It only increases by increasing the concentration of enzymes. I think this graph is understandable for you now. What is Vmax and what is 1/2 Vmax? And how it is happen, again, I am telling if the Km is equal to substrate, the velocity will be half of maximum. If Km is approximately 0, then the Vmax will be high. The V equal to the Vmax. But by these two statements, we can also get in one statement regarding the enzyme affinity. Okay? If the Km is very low, then enzyme affinity will be increases. Therefore, you are getting maximum velocity. If the concentration of Km is high on the large, then affinity of enzyme will be decreased, because we already know the velocity is getting decreased. Okay, it is Vmax half. If the affinity is high, you will get in the maximum velocity. If the affinity is low, then you guys are getting less velocity. That is understandable. Now I will read the lines that is written on the first rate. The first rate is a Km is a substrate concentration needed for enzyme to reach the rate of Vmax half and is inversely related to affinity of enzyme for the substrate. I already told you about this, that if the Km equals to concentration of substrate, then velocity will be half of maximum. And if the Km is a high, then affinity will be decrease. So affinity with enzymes will decrease. Now we are moving to our next statements. The Vmax is directly proportional to enzyme concentration. I already told you guys, if you want to increase, if you guys want to increase the Vmax, you have to increase the concentration of enzymes. Second, most enzymatic reactions follow a hyperbolic curve. I already showed you this curve and this curve because hyperbolic curve. And it is also a statement of the Michaelis Menten kinetics. The Michaelis Menten kinetics give that the enzymatic reaction will give you a hyperbolic curve. And in a hyperbolic curve, there is a one point. There will be one point where the curve will be flattened, and that point will be Vmax. And Vmax is only changed if you increase the concentration of enzymes. However, enzymatic reactions that exhibit a sigmoid curve usually indicate positive cooperative in substrate binding, like aspartate transcarbamylates. In these days, a sigmoid curve like that, and they will give a positive failures. Now, secondly, familiar with the same concept and with same equation that given by the Michaelis Menten kinetics, the V equals to Vmax multiplied by substrate concentration divided by the Km plus substrate. Okay. If we make inverse of the, if we can make a reciprocal of that equation, it will become 1 over V equals to Km plus concentration of substrate that will divide by Vmax multiplied by substrate. Fine. As you already give this equation, it's the reciprocal of Michaelis Menten kinetics. I will convert this equation, okay? Like it really be like that. The Km divided by Km this, we are going to separate this part and this part, the same denominator, okay? The Km with the Vmax and substrate. Giving us a plus sign, there would be substrate divided by Vmax and substrate. In that equation, you can cancel that, and in that equation, there's 2 points here. Km, what's it? Vmax. The Km divided by Vmax is actually equal to one constant character C. And now our equation is C multiplied by 1 over Vmax plus divided by 1 alpha substrate. Okay? This is our equation. And let me again write that part. Here we have in substrate, so we will write substrate only. And here we have in Vmax, we will write Vmax only. Okay? According to algebra, we having one equation. Algebra is equal to saying y is equal to mx plus b. Whenever this equation will be obeyed or converted, whenever y is equal to mx plus b, you will get a straight line in the graph. Oh, straight line in the graph. And if you see m, this is the x, I'm still not color, m, x, the plus, and this one is a b. So, according to Lineweaver-Burk plot, it is make a reciprocal of the Michaelis Menten kinetics and get the equation y equals mx plus b style. So after this equation, we are getting a hyperbolic graph into a straight line graph. Okay? So this is the same graph that we are doing here, the same graph, but after putting the Lineweaver-Burk plot, it will convert into straight line graph. Okay? And it is a more easier, and actually it is a more easier way to get the value of the Km or identify Km. How we will calculate the Km. Okay? Now we are going to explain this one. For example, this is a simple plotting. Okay? In this plotting, this is 1 over V, 1 over S. If I write my equation again, it would more clear to you guys. This graph, okay? Now our main focus is this one graph, okay? Whatever I write my equation that will given by a Lineweaver-Burk plot, okay? It's the 1 over V equals to C constant, 1 over substrate plus 1 over Vmax. Okay? According to this, the 1 over V is this, then C constant is this, and 1 over substrate is plotting on the x-axis, and 1 over Vmax is this. This is a straight line. If this ran, the point where the straight line is crossing the x-axis and the y-axis, that point is called 1 over Vmax. Again, I am saying the same thing. The point where the line it's crossing the y-axis is called 1 over Vmax. And the point where the line is cutting and going from the x-axis, it is the exact value of Km. Now it is coming that side, then the value is 1 over Km minus 1 over Km. Okay, it's the simple graph, a straight graph that Lineweaver-Burk plot gave to estimate or identify the value of Km. Now I will read for you guys these lines. The closer to 0 on the y-axis, the higher the Vmax value. Are you guys getting this in 0 point? As the closer the cutting, the Vmax value is higher in the Vmax. The closer to 0 on the x-axis, the higher the Km. Like as much I can tell you, in that graph. If you know about that graph, these sides are positives and this side is a negative. If the line is cutting away from the zero, then the value will go into minus, mean the value becomes smaller. If the cutting is coming here, okay, then value is in the less minus numbers, then value will be greater. The same thing is staying here, the closer to zero on the x-axis, the higher the Km, the lower the affinity. Already we are talking about in Michaelis Menten kinetics that if you guys having the higher Km, then there will be no affinity with the enzymes, okay? And when how the Km, what is the possibility of again dividing if the Km is equal to substrate, fine? And reversible competitive inhibitor cross each other, whereas a non-competitive inhibitor do not. That's the competitive inhibitors and non-competitive inhibitor. For that, we will talk about in our next lecture about the inhibitors, but simply I will tell you about this thing. For example, this one is the enzyme, okay? In competitive inhibitors, a substance seem look like substrate will attach on the active site of enzyme and block the pathway for the substrate, and it will make a inhibitor conditions, okay? And it is a reversible and non-reversible also, but mainly if you increase the quantity of the substrate, the reaction will be reversible and substrate will replace the inhibitor. But in the non-competitive inhibitors, for example, this is an enzyme, and this one is the active site, but the inhibitor come from another allosteric sites and attach here. And it is not chain, it is irreversible. If you increase the concentration of substrate, the inhibitor will not move anymore. It is a permanently damaged enzyme, okay? It's so all about today, and it is a totally, if I summarize this all the topic, okay, is summarized all topics of kinetics. Enzyme kinetics is totally about the philosophy, how much product is forming and how much time is taking in less time, okay? And secondly, it is a relation between the velocity and the substrate, and it is determined by one constant called the Km. If the Km is higher, then the velocity will be half of the maximum, and affinity will be decrease. And if the Km is less, then velocity will be V maximum, the Vmax, and affinity of enzyme will be increases. And it totally, all the things is explained by the Michaelis Menten kinetics in the hyperbolic graph, in which hyperbolic graph, what I didn't mention, but the Lineweaver-Burk plot give a straight line graph, but the things are same. Just the shape of a graph is the change. Okay, it's totally about today about the enzyme kinetics. We will continue very next class. Thank you.